Pearson's correlation coefficient. So that was the R value, and that was, we just had a little look. We could see that I had an R value underneath, and it told you what the strength of it. Remember, if the dots were close together, we said they were strong. If the scatter was a bit more apart, we said it was moderate. And then if they were really spread apart, we said it was weak, a weak relationship. So here in your notes here, you've got a guideline to describing. So we're going to show you how you get this R value in a minute. But the first thing is you got to know when you get the R value, how you categorize it. So if it's a number between 0.75 and 0.99, we're going to say it's a strong positive. Because it's a positive number, we'd say it's a strong positive relationship. If we had 1, we say it's perfect, remember? So, and if it's between 0.5 and 0.74, it's a moderate and then weak. And then if you go into the negative, and it's so if it's a negative number between 0.75 and 0.99, it will be a strong negative relationship. So we need to know how to do the R value on our calculator. So down here, so when you're working out the R value, first of all, you can only get it if you can do a scatter plot. And you can't do a scatter plot unless both your variables were numeric, so they're numbers. And we shouldn't really look at the R value unless we think that relationship is linear. So if the dots were doing like a curvy pattern, we shouldn't use the R value. It's not accurate. So only if we think the dots are following that straight line. And if we had no outliers. So, when you draw a scatter plot up, sometimes you're going to see this really odd little dot. It's floating out by yourself. If that's happening, we can't use the R value because it will affect the calculations when we do it on our calculator. All right, so we're going to we've got these 2 tests for a group of 10 students were given in the following table. Now, determine the correlation coefficient, which is the R value, for this data. So once again, it's crucial to know which one's the EV and which one's the RV. When you have a test, when you've done like a test with 2 classes, generally we're going to say that test 2 will be influenced by test 1. Because say if you don't know anything, how are you going to go on the next one? Sort of think of it like that. So when you have like 2 things like this, the earliest one would be the EV. So test 1's going to be the EV and test 2 will be the RV. So you might want to write that there. So now we're going to look at our calculators. So when we go into our calculators, we are to find the R value, we're going to go into our listen spreadsheets and you're going to type your 2 lists in. So we've already done this, prepared. So test 2 and test 1, test 2. So you've got your 2 lists in. So the way you get your R value is you're going to move this little cursor. Make sure you're sitting in a white box next to, even up the top will make it a bit easier for you. All right, so once we get there, and these instructions are all in your calculator, in your notes. So, sorry about that. Just delete that. So we're going to press menu. We're going to go to statistics. We're going to go to, stat calculations. And which one do you reckon we're going to go down to? What one have we been looking at? Yeah, the A plus BX. So we're going to pick that one. So you get up here. Now, remember the X list. Which variable is our X list? Yes, and it's the EV. Good. So in X list, we put the EV. So I call it test 1. And then underneath, you're going to go click the Y, which is your response variable. We're going to click test 2. And once you've done that, you can just, for you guys, because mine's a bit easier on the cursor, but you can just tab down and tab over to OK and click OK. So what you get is a whole little bit of data up there. And later on, we're going to use this. We've seen this before. Remember, we said A. Remember, that was our y-intercept of our straight line. And there's B, our gradient. If you keep going down, we've got R squared. We're going to look at that, but that's called something different. But we want our R. So there it is. There's our R, our correlation coefficient. Generally, they ask for 4 decimal places, which they did in that question over here. It said to 4 decimal places. So if I go back to my calculator, I would say the R value, R equals 0.9499. Now, if I was to rank that, what type of relationship is that? If we go back up here, what's a 0.94? It's a strong positive. Good. So that's how we would do that one. So if we look on to the next one, it doesn't matter if you haven't typed it in. I'll do it with you. It says the hours studying for each of the 2 tests were given in the following table. Determine the R value for this, correct to 4 decimal places. So just to practice again, I go into the listen spreadsheet. I just said hours T1 for test 1, and I typed them in, and then hours for test 2. Hours test 2. And I've typed them in. So just to practice again, to get the R value, menu, statistics, stat calculations, A plus BX. The X list, once again, it'd be the same. The hours spent will go for the first one would be EV, the second one, and click OK. And remember, I've got to move it down a little bit. I can't quite see R there. So this one, the R value is 0. Now, if I said it says to 4 decimal places, this one will be 0.8804. Because the 5th letter number isn't above 5, it remains at 4. Okay, so there's the R value for that. All right, then, so that's pretty easy. And then just going back to this, it says classify each of the strength of each of these from the previous table. So we're talking about this color chart up here. So let's have a look. What would R0.35 be? Would it be weak? A weak positive relationship? What about B? Negative 5.0. 5.0, does that fall in there? So that one's a moderate negative. What about this R would be a strong positive, and this one would be no correlation because that one's too small. It's like lower. So that one is that last one is in this pink values, isn't it? So that would be really random dots everywhere. There's no pattern there. All right. So even though we compare 2 things, like so I've got 2 numerical data and I compare it and I find the R value. When I say there's a strong correlation between it, just because there's a strong correlation between 2 numbers doesn't mean that they actually affect each other. It could just be coincidence and things like that. It might not be, it doesn't mean it's the cause of that. It could just be coincidence. So this is what we're going to have a look at, and I'm just going to show you a video on it, and it explains it really well. So we'll look at that in a minute, and then we'll go back over these notes after.